Now in the previous video, we took a look at blanket implementations, where if you have a struct right here called product, and then you have a thread here called priceable, you can come down here and using this implementation feature, add methods for this type called product. In other languages, you will have to define the methods inside the struct itself or the class, but in Rust you have to do it separately, and gives you a lot of advantages, as you can even do it in other files. Other people can also implement methods for your struct. Now we went further to show how you can implement a thread for a struct, just like in other languages where you can implement an interface for a class. This is how you do it in Rust. Doing it this way will ensure that the methods defined inside these structs are all implemented. Now we even went further to explain blanket implementations in Rust, where you can implement a thread for other types like structs that implemented other threads. So this way you can do something like group implementation, like I explained using the European football clubs example that I gave. You can check out this video here where I explained that. Now all these are good, but it also comes at a price. Now the question is, you can see right here that I was able to implement this priceable thread that I defined here for all other types in Rust that also implemented this display thread, and luckily for us, the integer type as well implemented this display thread. Therefore, automatically I've also implemented this method for integers as well. And you can see here when we run the code that for this integer type right here, for this integer, we are able to call getPrice on it, simply because we've defined and assigned this getPrice method to integer, and because it implemented this display thread. Now the problem comes in where you start talking about references and the orphan rules in Rust. In other languages will allow you to maybe take care of it or prevents your code from compiling, but in Rust decides to enforce it. So this is what it looks like. Now let's assume that you have a crate A and another crate B and then another crate C. But in crate A, we define this thread priceable, right? And for crate B, we define this struct called product. Now, just like in our former example here, we were able to implement this thread priceable for this product simply because we are still in the same thread. So what Rust does is it implements something called the Orphan Rule, okay, to make sure that references are taken care of. And it simply means that if you are on crate C, you cannot implement priceable for product, because both priceable and products are in different crates. So that is where the orphan idea comes from. So it's right here, it's like right here, this implementation doesn't have any of this as the parent. They are not in the same crate as either the thread or the struct. So however, if we were to move this right here to inside this crate, if this is where we implemented this priceable for this struct, then Rust is going to allow it, because you are doing it inside either the crate where we define this thread or the crate where we define this struct. The same way we can also implement this priceable for product inside the crate B. But once we move outside of here, then this implementation is like an orphan. It doesn't have any parent. Either the struct or the thread doesn't exist inside this crate C. Therefore Rust will not allow it. So this is how Rust enforces this references idea. Okay, so you cannot implement a thread for any type at all unless you are inside the same crate with the struct or inside the same crate with the thread itself. So this way Rust will prevent anyone. Imagine that this crate is somewhere inside crate.io, and then this one is also somewhere in crate.io, and then this is your crate where you are working on, okay, and then you decide to implement this priceable thread for this struct. It will cause problems because other crates inside this crate, you might have also implemented this priceable for this crate. Okay, that will cause a lot of issues and confusions. So Rust uses the orphan rule to make sure that you must be inside this crate or this crate in order to implement any of these for any of the types. So I hope this makes it a lot clearer. Make sure you like the video and subscribe, and if you have more questions about this, leave it in the comment description or get to our website